In this tutorial, we will be introducing the Flipbook node, which will allow you to animate your textures, the axis-aligned spheroid billboarding mode, which will allow your textures to keep a 3D appearance when moving around in the scene without changing their orientation, and how to create light particles. We will be creating a flame effect. We have created our own custom texture for this effect, which can be found in the description so you can follow along. The first thing we will do is create an empty effect. Then, we will create an event multiplier and a particle layer node. Normally, we use the editor's loop function to replay our effect while we're working on it. However, because we are making an effect that we want to loop forever, we need to have our particles live indefinitely. Disable the loop function. Then, with the event multiplier node selected, make sure that the duration is set to 0, the spawn count mode is set to total particle count, and that the spawn count is set to 1. Next, we need to set up our nodes in the particle layer so we can see our particles. Double-click the layer node and create a billboard node. Restart the effect by clicking this icon or pressing Ctrl-R. You should see one particle in your viewport now. It will disappear after 1 second and the effect will stop because we've disabled the loop function. In order to have our particle live forever, create an infinite life node and delete the original life node. For the purposes of this example, it is not necessary to add a local position to world node. However, we will demonstrate why it is good practice to do so. If we do not have a local position to world node, you will notice that if you try and move the particle with the translation gizmo, it will remain at the world's origin. This is because the billboard renderer expects world space positions as input. Here, nothing is plugged into our renderer, so the default value is 0, 0, 0. As we do not have a local position to world node, this ends up rendering particles at the world's origin. Normally, if you were to add the local position to world node, you would be able to move the particle properly with its position updating with each respawn. However, we are now dealing with a particle that lives forever and does not respawn at all. We now need to be aware of when our nodes are updating. In order to see this more clearly, press the P key and you will see the colors of your node graph change. There are many different viewing modes for the node graph that can be found in the upper left corner menu. P will cycle through all of them, while Shift P will cycle backwards, similar to the viewport viewing modes. We want to view the exec rate of our nodes. Everything that is colored red executes or updates once per frame, while everything that is blue executes once when the particle is spawned. The orange nodes are the ones that handle the rendering. As you can see, our local position to world node is blue, which means that it is only updating the position when the particle is first spawned. In order to make it update once per frame, we need to change the simulation state in the Properties panel to Evolve. If you try and move the particle with the gizmo, you will see that it will now work properly. Once again, it is not mandatory, but you'll almost always have to place this node in order to have the particles transformed properly. You can find more information on the world space and the local space in our online documentation. Moving on, we will now add our texture to the effect. In the last tutorial, we introduced textures with multiple images on them and described how to subdivide them and choose individual frames. We will now do something similar. With the billboard renderer selected, first change the size so that we can see our particle better. Then enable the Atlas option. Change the diffuse map. Now, depending on how you've set up your texture, you will need to input the correct amount of subdivisions. The left input field dictates the amount of columns your texture will have, while the right input field dictates the amount of rows your texture will have. We have set up our texture so that it is an 8x8 subdivision. We know that the texture ID is how we choose what image to display. However, we need a way to tell the system that we want all of the images displayed in a sequence. To do this, we will use the Flipbook node. Make sure your texture ID property is visible in the node graph, and then add a Flipbook node. With that node selected, in the Properties panel under the Input section, you will see several properties that will help us define our animation. The first frame ID will almost always be 0 unless you want your animation to start somewhere else on your sprite sheet. For the last frame ID, input 63. Now, we must define the time frame, speed, and repetition of our animation. The cursor mode allows us to choose by which metric to measure our timeline with. We will choose Effect Age Evolve since our particle is infinite and its life ratio will always stay at 0. The cursor range and cursor scale define how long our animation is in terms of the timeline we selected. The higher the range, the slower the animation will be. The higher the scale, the faster it will be. Currently, our animation is a bit too fast, so we'll change our cursor range to 2. Repeat allows us to loop our animation, while reverse allows us to play it backwards. You might not notice it at this speed, but if we slow down the simulation speed and zoom into our texture, you will notice that the transition between the frames is a little bit rough. Generally, this is not a problem for effects that are in the background and not the focus of attention in a scene. However, if this is not the case and you want to polish your effect, you can use something called linear animation blending. So that you can see the difference, we will create another copy of the effect and place it right beside our original. We do this by simply creating another billboard, linking the Flipbook node to it, and linking a local position to world node with a different position value. Click on one of the billboards, and in the Atlas section, you will see a blending drop-down menu. Blending interpolates between frames to make the transition smoother. By default, it is set to none because blending is a bit heavier computationally than no blending at all. Select linear and you will see the difference in between the two effects. Blending should be used sparingly and only in cases where it is really needed. If you resume the simulation speed, you will see that you can barely tell the difference. Next, we will go over 3 different billboarding modes. Currently, our billboarding mode is set to screen aligned. This means that when we shift from side to side or we rotate our camera on any of the axes, our effect will always face us. For the most part, it is not a big problem if your texture is symmetrical. However, you can run into problems of perspective when viewing the texture from above or below. Another common billboarding mode is axis aligned. This mode locks the texture on a defined axis. We also run into problems when viewing the texture from above because it disappears. The other billboarding mode is axis aligned spheroid. You will see that your texture shifts slightly. In order to understand what this billboarding mode does, we will turn on the wireframe viewing mode in the viewport and stretch our texture so that it is more rectangular. Link a float 3 to the axis pin of the billboard and change the upwards direction value to 2. Now, when you begin to move above the texture, you will notice that the longer side begins to shrink according to perspective. This mode is like a combination between the screen align mode and the axis align mode. It allows you to create the illusion of perspective without changing the orientation of your texture. Now, we can get rid of our other 2 billboards, the other unused nodes, and the wireframe, and start working on making our fire texture look a little bit better. Our texture is already colored, but we can add a small glow to it. Link a color node. Then, increase the value shift. Make sure you don't set this value too high, otherwise you could lose detail from your texture. This looks pretty good, but we can take it one step further. We will add a light to our fire so that the surrounding area is affected by its glow. Before we do this, we need to make adjustments to our scene. In the PopcornFX editor, light particles only affect solid objects. So, we will add some terrain to our scene. On the bottom of the layer panel, you will see 3 tabs. Click the Scene Properties tab. From here, you can tweak a number of different parameters that change the environment that your particles are spawning in and how they are being rendered. Scroll down to the Backdrops Mesh section and enable the Mesh Backdrop. Next, we will choose a mesh for our terrain. Click the Mesh path and go to the Meshes folder. Select any of the Cube Room files. Then, we will add a texture to it. Navigate to the Textures folder and select any of the Editor Model Ground files. Then, input -1.5 in the vertical position input field. Now we're ready to create a light node. You can see that it has 3 pins that we can link nodes to. First, we will set the position. We want our light to follow the position of our fire, so link the local position to world node to the light's position pin. Afterwards is the range. This controls the radius of the light. You can also adjust the fall-off of your light by changing the attenuation steepness value. In order to see the light, we will need to increase its intensity. We do this by scaling the color node. Add a multiplier node and scale the color by 15. Next, we want our color to be the same as the source. But because our texture is already colored, we will have to recreate another color node and match the color. Now you should see your light. The light itself is static, which doesn't make it seem like the fire is producing it. There are a number of ways to make the light flicker. One of them is using a curve over time and curve node as we have done in the past. However, there is another method that is a bit quicker in achieving more or less the same thing. In the V2.2 editor, there is a new template called Flicker. Create another multiplier node in between your float and your original multiplier node. Then, link a flicker node to it. In the Properties panel, we need to change the cursor mode to Effect H Evolve since our particle is infinite and its life ratio will always stay at 0. Then, under Animation, we can tweak different properties to change the range of the flicker and its speed. We will change the speed to 5 to smooth out the flicker. We want a larger range of values for our flicker, so we will set the minimum range to -1. Lastly, the base value is the lowest value that the light will ever be. We never want the light to be at or too close to 0 since our fire is constantly burning, so we'll move it up to around 0.5. Now you should have something that looks like this. That's all for this tutorial. We hope you found it useful. Stay tuned for our next one.